And we are live. Hi, everyone, and thanks for tuning in. Sorry for the bit of delay starting this broadcast. I had some issues with the microphones. I'm using a backup microphone at the moment, so I'm using a headset microphone, which might be a bit clunky when we do some testing in VR, but we'll work it out. All right, so I guess let's get started. In the last live stream, we've looked at creating a new VR project from scratch, which is not really rocket science with the current engine version. So for this live stream, we'll still be using the latest engine version, which is 4.17, with 4.18 coming up perhaps this week or next week. All right, so let's see what we've got for today. We're going to look at the Locomotion in VR. We're going to recreate the flight mechanic using blueprints in Google Earth VR and Lone Echo. We're also going to do a free movement style or a 360-degree movement style using the thumbstick or gamepad movement for both the Rift and the Vive. So the project that we are going to be working on, similar to the first live stream, is going to be both Rift and Vive compatible. Throughout the development of this mechanics, we're going to look at we're going to be doing it in an incremental approach, a VR development, sample VR development workflow that you could be you might want to use. We've got also a BP to UE flavored C++. So we're going to convert some key algorithms that we're going to come up with in this stream into C++ from Blueprint to C++. And after that, we're going to look at through Q&A. And then I'm going to pose a couple of challenges for you guys afterwards so that you can do some stuff on your own. And we're going to talk a little bit about the next stream as well. So just a little bit of clarification on the VR development workflow. It's going to be an approach where we do a prototype in Blueprint, which is what we're going to be starting with. And also this helps kind of a little bit for those who are not too familiar with C++ or are afraid to touch it. I'm going to be trying to ease you in to the C++ world of Unreal by doing prototyping in Blueprint, and then things that we would think of or we might need to make more performant, we're going to convert to C++, which is kind of like an ideal VR development workflow, or how it works with bigger projects that I've been to anyways. So, all right, so before we begin, let's get started with a little bit of housekeeping. So I've created a new GitHub repository. So it's one Runberg Livestream VR AR 01-10, or just go to my GitHub page, and you should see the live stream here. All right, and from here, I've added the episode 1 as a branch. So all of the episodes will be different branches. So if I go back to branch episode -01, I would see the code that we've covered during that live stream. So I've kind of modified this a little bit. I did it this morning. All right. So, and if you want to see the commits, if you click on commits here on the branch that you're in, you would see each of the different steps that we worked through during that live stream. So this kind of helps you if you're backtracking to in this live stream, or watching it out of a video, or even following along, you could just immediately see what step you're in, what was done, and you could even, if you clone this repository, let me just try to find my source tree. There it is. You could immediately go to the different states of the project just by going to the different commits. All right, so if I now, let me just put up my key here. So you could see that for the different branches, you could have different commits. Let me just put that in. If I go back to master, master would always be the last episode. So go back here, sorry. Yep, so master would always be the last episode. So 02, and I'll be doing commits while this episode is running. So just so that you can backtrack in the future onto the different stages of the project. All right, so with that bit of housekeeping, let's go to our project where we left off from the last episode. So it might look a little bit different. I kind of try to make it look a little bit nicer. So I've added a couple of the materials and meshes here that came with the plugin. And for this project, I'm not going to be using the plugin, so it will be more a tutorial series on how you can do things yourself. And I'm still going to talk about a little bit about the plugin at the end. But the purpose of this stream is to kind of teach you how to do it yourself and to do things from both the Blueprint side and the C++ side. All right, so let's open up the VR pawn. And I've just done the begin play basic VR Rift and Vive setup, which is just enabling the HMD, setting the tracking origin to the floor level, and doing all of the basic setup that we've discussed on the last live stream. So that should give you a VR ready kind of basic template that you can start off with. And all right, so now let's do a little bit of locomotion. If we have a quick look at this, this is how our pawn looks like at the moment. And if you do this, this is the x-axis, and this is a movement. This is the how the pawn is facing at the moment in the world. And what we want to do is to be able to create a simple movement mechanic where you kind of like in Lone Echo or in Google Earth VR, where you go to the direction of where you're pointing your motion controller at. All right, so how do we go about doing this? So I'm gonna approach it from a point of view of like developing it from scratch and developing it as in an incremental or iterative approach, just so you see how a code could evolve from something simple. We'll do simple stuff all throughout to making it more complex. All right. So what do we need to do when we do motion? So obviously we'll need something that happens every frame to make the movement smooth. And in Unreal, that event is called event tick. Right? So we'll need to have something in here that happens every frame, so every tick, and then move the pawn towards the corresponding axis, right? So our pawn would have, if you think about it, our pawn would have two states. One is if it's moving, and two if it's not moving. So we kind of have to check every frame. Is this pawn moving? If it's moving, then run the code that moves the pawn to the direction that we want. Okay, so let's look at that means we'll have to create a variable. So I'm creating a Boolean variable here, so called isMoving. Right, just gonna expose that there, make it visible. Save it, and the default, once you click compile, if you create a variable here, you set the variable type to Boolean or whatever variable type it is. The default value won't come up until you hit compile. So I've hit compile, and then we want it to be false at the start, right? Because we don't want the pawn to be constantly moving. We only want the pawn to move when we do something with the motion controller. All right, so we'll get to that in a bit. But for now, let's just ensure we'll get this. I'll drag it there. I'll drag that pin in there and type branch. And do that. All right, so now we have a quick test on every frame. If we want the pawn to be moving, we do this. If not, we do this. All right, so what do we do when it is moving? So let's do the actual coding. portion for this. So in a movement, we have both the start location and the end location. So let's look at the start location. So getting the current location, so we'll just get actor location. So that will be our start, and we need to add something to this start location. So all pretty basic so far. And now comes the tricky part. So we want it to be moving into a direction of where we're facing. So we need to look at the rotation. So we're gonna get the actor rotation to begin with. All right, and since this is a rotation, we need to convert this to a vector. So it's nice that Unreal has a node called that can convert the rotation to a vector of where it's facing at. So convert the rotation to a proper direction in vector format. To do that, because we want it to be moving forward, so we do we get the forward vector here. So that's a node you need. And then we need to multiply this vector by the speed that we want the pawn to be moving on. Because right now this is 1, so that's a 1 unit. And if we want to do speed, let's create a variable called speed here. So I don't want that to be a boolean, of course. We'll want it to be a float. So there's no default value, could you see there. And let's use 5 as a default value for speed. And then we just multiply this. So I'm just pressing asterisk on my keyboard. So vector times float. And we'll punch in the speed here. So the reason I wanted that to be a variable so that it's easy for someone else to or for you to actually edit it directly from the variables without having to look at the blueprints here. All right, so always a good rule of thumb when coding. So minimize the amount of, or actually don't use a lot of magic numbers as we call it in programming. So anything that's above 1 should be set as a variable. So it's not a hard and fast rule, but it's a good, very good rule to abide by in development. So I'm just going to add that in there. So now we have a basic movement code. So we're getting the current location of the actor, which is the pawn. We're adding that to the actor rotation. The forward vector, multiplying it there, then adding it there. Now we want to do now we actually want to do the action itself, which is to move the actor. So we're gonna set the actor, let's use set actor transform, which gives us the spin here, which is a new transform. I'm gonna split that. And we're gonna have a transform location and a rotation. So every time that's true, let's set that in there. And this will be our location, right? So I'm just gonna move all of these codes here so it's a little bit more readable. And the scale will keep as is. We don't need to change the scale of the pawn. We'll get the actor rotation. So because we want it to be using the same rotation. All right, so I don't like crossing cables or lines here for blueprints. So you got, all right, so we've got a pretty basic setup going here. And we could immediately test this on the viewport. So let's have a simulate. And it's not moving, simply because our is moving is set to false. So we'll do that just for testing. And you could see that it's moving towards where it's facing. So that's a very simple movement mechanic that you can implement quickly, not only in VR, but I guess a lot of other different actors. So I'm just gonna tidy up a little bit, and let's put a comment here and say flight movement, right? There we go. So change the color maybe, cyan. All right, so we're doing the test here and we're doing the actual code here. All right, so let me just looking at that there, let me just remove that we are live. I was in there for a while. All right, so we've got the flight movement mechanic. Now we need to ensure that this only we need to be able to ensure that this only runs when the player wants to. So we need to create an input for this. So what would be the input? Let's use, for simplicity, a trigger. So obviously you can use any kind of input you want. That's within the motion controller, but we'll, for the purpose of this, we're going to be using the trigger. So let's start off with the left trigger. All right, so when it's pressed, I want to be moving. So we'll set that to is moving, right? And when it's released, I'm going to press this, Control W. I don't want it to move, so that takes care of that kind of Boolean gate in there. All right, so left trigger pressed is moving, released is not moving. So pretty simple so far. So we're doing it stepwise. So now we've made it moving and doing a test. And now we're actually enabling the player to be able to set that test in here. So it's moving and it's not moving. So pretty simple. Should work. So we should test, of course. All right, so I'm just gonna do that in here. Give me 1 sec. Click VR preview. All right, so now I'm in VR mode. Just gonna get my motion controllers up. All right, so we're pressing the trigger and we're moving. So we're moving in one direction, which is the direction of the pawn. So it's not following, as you could see, it's not following where I want it to go. Like where I'm pointing at is where I want to be moving. Why is that? Let's have a look. Because, sorry, let me just set my headset up. Okay, so we've done the basic movement. We're able to start the movement and end the movement by pressing the trigger and releasing it. But the rotation, obviously, is still is not quite as we want it. We want it to be moving to the direction of where we're pointing the motion controller. So as you could see here, the only thing it's doing is getting the actor rotation and getting the forward vector out of that. That's why it was doing like just this one forward movement. And the only thing we're doing in the input is just enabling the movement and disabling it. So what we want to actually do is change this one into the rotation of the motion controller. So right now we're doing it on the left motion controller, and we just want to be able to test a full flight setup. Sorry. So we'll do a get world rotation, and then that rotation then is what we plug in there. All right, so we're looking at motion controller left because we're only triggering it from the left at the moment. And we're getting that forward vector and we're doing the movement. All right, so let's try this again. Okay, so you're just using the left hand. Now I'm flying. So we've done just a very basic setup and I can fly around this world as much as I want to. So, and I'm pressing the trigger and I'm just pointing it. So I'm hoping I'm not giving anyone a headache. I like this mechanic. This was one of the first mechanics I've made for my plugin. Because I, back like more than a year ago. So it's like, when I first got my VR headset, I really fulfill the childhood dream of flying. So yeah, so I'm just pointing and then pressing the trigger so you could see that I could freely fly around this world. All right. Okay, so now to make sure that it actually works for both the left and right controller. So since we're practically hard coding, we're well, not practically, but actually hard coding it. So the motion controller left here, we need to create a variable to put in here so that we can control it from whichever event input that we're trying to allow this code to run on. So if I do motion controller right, for example, motion controller right trigger, there it is. I'd basically be copying and pasting that here, and I need to be able to set this thing to the right motion controller, so we can't just set it to left motion controller here. So let's remove that. Let's create a variable. So all right, so I'm just gonna rename this one sec to, let's call it movement reference. All right, so we have movement reference. And all right, so what is a variable type? We can obviously use a motion controller. Okay, so motion controller reference, and that should work, right? But if, let's say, I want it at some point to be the camera, or I want it to be at some point to be something else, then I would have to keep changing the variable type, and I could break things. So not really necessary for this stream, but I just kind of want to quickly show that. If I have the API reference here. So let's look at the motion controller here. So let's look at the class, U motion controller components, so U Unreal. So you could see that you could, this is the hierarchy, the class hierarchy. So we start with the object base utility, and then object inherits from that, and actor component, scene component, and primitive component. So the primitive component would have all of these children here. So that means you will be able to change the different objects on that variable, or you could set the different variables to any of this type of objects that are seen here, or you could go to the scene component, then you could have camera, right? So let's look at that scene component and then check if you've got the location and rotation, which you should have. All right, so that goes all the way up to the scene component. So let's do that. So let's use a scene component. If we go back to Unreal, so let's change the movement reference to any scene component. This allows me to have a movement reference for, I could use a camera, I could use a motion controller, I can use a static mesh, and what have you. That's part of that hierarchy that I just showed. All right, so obviously Unreal is complaining with this thing here, with that node, and we're just gonna use this one, get it, and do that. All right, so we've got a movement reference, we get the world rotation, we get the forward vector. At the moment, the movement reference doesn't have anything here. So what should we do? What we're going to be doing then is we would want that when we press something, we want to set the movement reference and then set the is moving, because we don't want it to be moving without that movement reference, and you will get some null check errors in there, which we'll get on in a sec. But let's do this. So I want this movement reference I want to set something here. So I'll do that. And for the movement reference in this left trigger, I'm going to use a motion controller left as our base. Just going to clean this up a little bit like this. All right, so now we can set a motion controller left and see if it's still working. So we just quickly test it. So I'm going to have to put on the headset. Just hoping I would. So now I could still fly. Okay. All right, so just bring back my microphone. All right. Okay, so now we have the motion controller left, and as you can see, it's now an easy matter of just copying and pasting this and setting a different movement reference, right? And at this point where you're doing duplication of code, it's always a good idea to think, should you put it into a function? So a function is something that you can call each time and then just change variables so that the actual logic is set or defined just once, and then you kind of reuse that block of logic. So we have a fairly simple logic in here, must admit, but I think it's worth it, at least for for this live stream, to kind of convert this into a function. So we're gonna use a function. We'll create a new one. So let's say it's set movement state, right? And in the movement state, we're gonna want to first have the movement reference. So what did we agree on? We agreed on the scene component. And we're gonna do this part. So I'm just gonna copy that in. I'm not gonna cut it because I just want to be able to see if I'm doing things right. So now the movement reference would be, instead of this, is anything that we plug into this when we call the function, okay? And we need an is moving. We need a movement state. So we'll create a new parameter, change it to a Boolean. Let's just call it is moving as well. Oops. Sorry. Is moving. And then just set that to is moving. And that's it. We've got a fairly simple function in here. So now let's do that for the right. So we've got that for the left, and so now we're going to set it for the right. So set movement state. We'll do that. We'll have it moving, and we'll have the movement reference here. Oops, sorry. What am I doing? I need to use the motion controller right. Set it in there, and Control W. And release. Set that to this one. All right, so now we have that. We have our prototype here, and we have the function that we just created working in here. So we have one node instead of two nodes. Okay. All right, so let's try this and see if it works. So you're using my right hand. Okay, so we now have the same functionality on the right hand, except I seem to be still moving. So, and that's the reason why there. Okay, let's try it again, just to be sure. Yep. All right. So, although you notice that it's, it will work, but it's always good to try and test, just to be sure. All right, so where are we? So now that we know that we've created a prototype, we've converted it into a function, a blueprint function, then we could just basically remove our prototype here. Maybe not all of it. I want to retain that reference in there. Okay. And just copy this function in there. Can remove this. And then plug that in there. And when it's released, that should still work. Because it doesn't matter because we're not setting a movement reference. And we're setting the is moving to a Boolean field here. All right, so now we have flight movement. Really simple flight movement. Okay, so, and that's how quickly you can create a flight movement mechanic. So it's input flight movement. Sorry. Okay, so got input flight movement and we've got the actual logic for the flight movement. All right, so let's give it a different color. Just be consistent with it. I don't know, maybe yellow. Okay. All right, so for those who are not familiar with the comment block, it's just selecting a series of nodes. Press C on your keyboard, C for Charlie, and then that should come up and encompass your code. So it's like this, select, and then C, and then the comment should come up. All right, so we've got flight movement, we've got input flight movement. I think this is a pretty good point. Actually, we should have been committing a little bit more often, but let's have a look at what we've got. So we've got uncommitted changes. I think it's a good place to actually commit some stuff. I'm on the master, just make sure I'm on the right branch here. And flight movement, blueprint, right? So we'll commit it. And gives us also a nice little break. Right, I should have said that before, but all right, so we've got the flight movement. All right, so what have we covered so far? So we've got this. So that's a similar movement mechanic that you have with Google Earth VR and the Lone Echo games, if you're not familiar with what I meant by flight. So now the slightly more complex one, which is the free movement. So what it is when you move the thumbstick or the gamepad for the Vive, you want to be able to move in the yaw or in the y-axis, so that whenever you press forward on the thumbstick, you move forward. You press left, you move left and right. So it's not a flight movement, but it's just 360 movement within one axis, within the x-axis. So, and some people do like this type of movement. So a lot of people do get sick with this type of movement, but for those who don't, or for those who want really like the idea of this type of movement, I'm gonna show you how to create one here using blueprints, and then we're gonna convert it to C++. All right. Okay, so there's gonna be a bit of math for this one, a lot more complex math. Okay, so let's have a look. What is gonna be the main thing with this type of movement mechanic? We're gonna need, let's see if I can find a input UE4 Oculus. Just have the thing here. Okay, so we could use either the Oculus or the Vive, it doesn't matter. So here, at this point, if it ever comes up, okay, it's a bit of hazy version. Is there a high-res version? Yep, this one. So when you move the thumbstick here, in the X or the Y axis, we want to be able to move the pawn on that movement. So we've got this values coming up from the motion controller. And so you basically have an X and Y axis. And in Unreal, that event is called event motion controller. Left X, thumbstick X, yep. So you've got the X and you've got the Y axis. So sorry, left still. Tick Y. Okay. So that's the event. And if you hover over this, should tell you what that event does. So this event provides the current value of the motion controller. Thumbstick X axis once per frame. So this happens every tick as well. So when input is enabled for the containing actor. So that means since this is a pawn, the input is already enabled by default. But that means it's doing this, kind of something like this. So it happens once per frame. That means already tells you that we shouldn't be using this one because this already happens once per frame. And it gives you the value of the this thing, of the X and of the Y axis. So, all right, so that's the first thing to consider. Since we're gonna be doing this every frame, and we wouldn't want to be doing this here, but we want the same movement mechanic, the base movement here, this base code here. That means we're going to be reusing this block of code similar to this one. And you normally, as I mentioned earlier, like for this one, you normally don't want to do a copy paste simply because at some point in the future, for example, you wanted to change some stuff here or add some stuff into, let's say, set movement state. You want to do a couple more things, let's say add sound or play an animation or something. You wouldn't want to be changing it each and every time, right? So you want to be changing it on one place. Hence, you create a function. So that means first thing we need to do is to create a function out of this thing. All right, so that will be the simplest thing to do before we even touch this. So what we're doing now is called refactoring. So we're going to refactor the code a little bit to move it here. So, well, not strictly refactoring, but refactoring nonetheless. We're going to move, let's call it move pawn. Okay. So what do we need as an input? So we don't need any outputs. We just need an input. So we need, let's see, we need a movement reference so that we can get the world rotation, right? And let's just copy this entire thing in there. Okay, I'm going to remove the comment because it's going to be redundant. Right, so flight. So that's what we want to do. But we want to be able to set the movement reference. Because actually this entire thing. So if we want to be able to set the rotation. So we want the movement reference and some sort of rotation. So when we're just on the refactoring stage, we just simply want to move this out into a function. So that means just to make it less complicated initially, I want to be able, once I refactor, I want to be able to make sure that the thing still works. So let's just do that first. All right. So let's do a movement reference. So we have, sorry. Actually, if you think about it, the movement reference is actually part of, this is actually accessible. We don't need to plug it in here for the movement pawn. So we're not gonna reuse that. Let's just add it for simplicity. I'm gonna do, what did we agree on? Scene component, object reference, and we'll call it the movement reference, because I also want to do something else. So every time you use something like a pointer, like this one, we want to be able to check if it's valid, just so that you don't get any one-time errors. So branch. So if the movement reference is valid, then we do the transform. So we should not be doing the transform if there's no movement reference set. All right, because then this would come up with an error. So at the moment, since we're just refactoring, I'm just going to remove this and plug that in there. All right, so we just added a quick check, which we should have done anyways in here, I think. Yep, and then just gonna move this out, just so that you have a reference for the code that was still working before you did the refactor. And then we're gonna do a move pawn. Do that. So that entire thing becomes this one node, and the movement reference is basically this one, the global variable for this pawn. Okay, so, and we just quickly try it. So we basically just did a refactor, and we just want to try it. Okay, so we're still working. Yep. All right, so we've got a movement reference, and just looking at the, and hi Toman 2017, welcome to the chat room. All right, so we've got the move pawn movement reference, so we know that this is working. So to those in Twitch, just type in your questions if you have some, and I'll try to answer it. I'll quickly look at that. I have a separate computer to look at the chat, so I might not be able to answer you immediately, simply because I'm not looking at that screen, but I'll try to gaze at that screen once in a while and then see if there are any questions. So if you have any questions, post it in Twitch. All right, so I'm gonna remove this flight movement now because we don't need it anymore. So now we've got, and I shouldn't have moved the, okay, so now our blueprint, as a side effect of doing the function and refactoring like that, is our blueprint becomes a little bit nicer and cleaner. Okay, so we're doing the move pawn. That means we can then call the move pawn here at some point, right? So move pawn, which is, instead of dragging and dropping, I basically did a right click and then typed in move pawn. All right, so at the end of it, we'd want to be able to move the pawn onto a certain direction. So either, since we're doing a movement reference, we could create a static mesh here and then move that mesh like an invisible mesh, or a scene component with nothing in it, and then use that as a movement reference. That's one way we can approach that. But that means we're gonna add a component which basically does nothing but just move around. Let's try to see if we can do it more in a math way. First, let's figure out, before we think about that, since everything is working, let's think about the equation that we will need. What's the rotation? So in here, if we do the move pawn, let me just move this here. This forward vector in here, we're getting it from the movement reference. So we're getting a world rotation of the motion controller here we need to be able to convert this x and y axis value to a rotation in the yaw axis. So the yaw is the y axis here. Let me just see if I can easily visualize this. Perhaps if we do, yep, something like this. So if we do a rotation, so the yaw would be this green thing here, which is the y-axis. So that's going to be the yaw. So we'll be able to move around this green axis on the pawn simply by moving the thumbstick to any which direction. So we're going to have x and y. If you've been asleep on your trigonometry classes, or like me playing Super Mario at that time, out sick playing Super Mario instead of going to class. The equation, there's a trigonometric function to do this, which is to convert an x and y axis in one plane into degrees, right? So, well, radians. So it's called arctangent 2. I'm not gonna try to explain all of this, but that's the main. If you want to read up on it, look at Wikipedia or brush up on or look at your old trigonometry books from high school or whenever you touch trigonometry, and they could explain the details. So it's classically arctangent 2 yx. So you specify the y and then the x-axis, feed it to the arctangent 2, and then you would get a radians, which you then need to convert to degrees. So radians to degrees, and then you would have an angle in one axis, which is this axis here. So in a nutshell, that's what we need to do. So arctangent 2 is it's considered a basic math function. So obviously Unreal does have it. So you just have to look tan 2, and in blueprints it's really nice. You could see that you can do it in radians or you can do it in degrees. Since we need it in degrees, we'll just use degrees, this one. So as you could see from here, on the equation, classically it's y comma x. Right, so we're gonna put y in here and x in there. So yeah, move this around. All right, so y and x. So I'm gonna plug in y, and then I'm gonna plug in x. And that, since it's already converted to degrees, that gives us the degrees on the yaw axis in the green. From here, that gives us this axis here, and a rotation has x, y, and z. So roll, pitch, and yaw. So roll, pitch, and yaw, and we need the yaw. Okay. Sorry. Okay, so let's get the actor rotation. Right. So from the actor rotation, I'm gonna split this struct. I'm gonna get the x, which is roll. Y is pitch, or for here, the z value is the yaw. So sometimes it's kind of one of the frustrating things with Unreal sometimes, is that you could see here y it's different, while on the nodes it's different in Blueprint, and it's also it's also different in C++, as we'll see later on. Okay. So, but it's a good thing that they now have this, because if I remember correctly, earlier versions of the engine don't even have this. We kind of sometimes get really confused. All right, so we're looking at yaw, which is that axis in there, which is always a yaw. Okay, because roll is like this, pitch is like this. So an easy way of thinking about it, if you get confused on what roll, pitch, and yaw is, pitch, yaw, we should have. It comes from the planes. Yeah, something like this. Yep, this is perfect. Okay, so Roll is like this. So if you ever get confused of what roll, pitch, and yaw is, so roll is like this. So where the plane rolls. Pitch is imagining a flight takeoff and landing. Pitch. Maybe this is better. Let's see. Yeah, and then the yaw is when you're moving sideways. The words here. Let's have a look at. So I think this one's slightly better. So roll is you roll that plane. Pitch is, well, yeah, you're either landing or taking off. And yaw is you're moving left and right. So what we're looking for is the yaw. Okay. All right, so we're gonna want to add this degrees to the current yaw. So do float plus float. And then we're gonna convert this back to a rotator. So roll, pitch, and yaw. All right, and this rotation here is what we need to feed here in the movement reference. Or I guess we're gonna need another parameter. So we're gonna need to send a parameter here where if we have a rotation, then we're gonna use that rotation instead of a movement reference. All right, so that's the simple equation to get that degrees and then to move the pawn. So let's just convert this pawn back. So I'm gonna double click here and then it opens that up. So we're gonna need the new input called rotation. So where's my rotator there? Now let me call it forward rotation. Okay. So now, oops. In move pawn, we should have a forward rotation here. And let's reuse what's already in here. So if it's valid, if we have a movement reference, then we're going to use this. If it's not, then we're going to use the forward rotation. So either I can copy and paste this block of code, which I don't want to do. You never want to do all this copying and pasting, or duplication of code, basically. Or I can set a local variable. So to kind of save that rotation. So I'll call it new rotation here, just so that it's a bit different from there. All right, so let's call it rotator in here, new rotation, set that, compile. So when it's true, we want to be able to set the new rotation, set new rotation to this thing, right? Okay, so gets a bit messy now. We're gonna move it like this. I'm gonna move this here. So we don't need that plugged in there anymore. All right, so if it's true, we do this. I'm gonna do that, I guess. So it's one of the things with blueprints. It's gonna try to make it not messy as much as we can. Yep. All right, so I'm gonna do that. And right, so but if it's not, right? So all of this still stays true, but the forward vector, we're getting the new rotation now, right? So okay, so now that's the correct rotation, and we're still going to use the active rotation. That's fine. But if it's false, we're going to do something different. So if that's false, we're going to use the forward rotation that we've fed in here. And since this is just a series of floats and it defaults to 0, 0, 0, it's safe to use it without having, you don't even, because it's not an object basically, so you don't check for valid. So you don't get null errors with it. So I do that, and that's it. So we're basically setting the new rotation depending on whether there's a movement reference set or not, right? And then there's a new rotation, and all of this code still stays here. And we've got a reusable piece of function that we can use on the two different movement mechanics. So now we have that, and we just plug that in. And since we're plugging in no movement reference here, that will become null. And both of this now can just go directly to this. And yep, not the best blueprint setup for now. And so mathematically, that's how it should work. So we could just do a quick we could just do a quick test. Sorry, I'm just looking at the Twitch chat room. Tom, not sure what you mean by no PB. Is that no problem or no audio? So just checking my status here, and it does look like I have an audio. So if you could just type in there that you can't hear any audio, and then I can have a closer look. All right, so the thing here is that this happens every frame, and I don't want this to be called every frame. One, it's expensive, and since this equation would always come up with something, we will get some weird motion. Actually, we can quickly test that. So yeah, so you can see it now. I think we've flown off somewhere because you can't see the floor anymore. So we're moving in some weird direction that's coming out of that, okay, out of this equation here. So we don't want that to happen. What we need to do is, if you look back at the way this is happening, when you're here at the center, or when we're not doing anything to the thumbstick, it's 0. So we need to be able to catch that here so that it doesn't run every frame. So let's move this a bit further off, like this, because what I want to do now is, if the x is not equal to this 0, branch, right? Okay, thanks, Tom. So Tom was just confirming that we've got audio. It's perfect. So if we've got not equal to 0, move that there. So it's a little bit messy now. We fix it in a while. We'll see how it works first. And we're gonna have to do the same thing for the y-axis. So not equal to float 0, do a branch there. Okay. And if it's true, we're gonna push that in there. All right, so we've got a very nice spaghetti code. Haha. Not exactly something to be cheery about, but let's see if we can fix it a bit. All right, sorry, the yaw should go in there. Press Control, select all of these nodes here that I kind of want to move. Let's see if we could make sense of this. Yaw, that should be fine. Move this one down. So I'm just doing some basic cleanup so it's readable, or somewhat readable, as much as you can with blueprints. So you can have that there. So we can move this a little bit further, like this. Make it somewhat readable. Can't prevent this crossing here. Okay, so sometimes you just really can't prevent lines crisscrossing each other. So at this point, I would normally do a comment here and explain why I've done things. But for now, because then it will be a bit crowded, we're just gonna leave it as it is. And at a basic level, that's how we should be doing things, right? So arctangent to y comma x, and then we get the active rotation, get the degrees from that, add it to the rotator, make a new rotator, and move the pawn based on that rotation. Okay, because we're now getting the correct direction from here. Right, should work, right? So we have, I'm gonna press C here, and we're gonna call it flight movement. Okay. I think I use something like cyan. Yeah. And yeah, so since I've done this more than once, I know for a fact that it won't work as we intend to. But if I'm going about it as if I'm developing it from scratch, and then so that you could see the process. So, all right, so mathematically, based on math, this should work, right? So if it's true, then we move the pawn, and then we use the classic trigonometry, arctangent 2, so nice of Unreal to give that to us in degrees. We don't have to calculate it manually, and then add that to the yaw and move it. All right, so let's try, see what happens. Okay, so I'm gonna put on my headset now. One sec. Oops, sorry. All right, so I'm gonna press forward. As you can see, I'm moving back instead of forward. I'm gonna press back, and I'm moving forward. So I'm gonna press forward again, and I'm moving back. I'm gonna press left, I'm moving right. I'm gonna press right, I'm moving left. So something's gone wonky, right? So when I press forward, I'm going forward, back, left, right. So, and then, so the X and Y axis seems to be off. Let's see. So I can explain the math that goes along with this logic. But the beauty of doing things in VR or game development in general, I would say, is that a lot of these things you could intuitively fix. Right, so arctangent y and x, they seem to be inverted. So let's try inverting them, if we can. I'm pressing Alt, and see what happens. So X and Y. So before we do a bit of cleanup, let's try that again quickly. So I'm gonna press forward. So I think that made it worse. Forward and back, forward. Okay, so that means if we do the X and Y, that doesn't work. Obviously because of the rotation there. One sec. So we have to put it back and do the inverse. Right, so intuitively you could see how that works out by simply doing a test. Right, so just kind of wanted to show that. So we do arctangent 2, y, x, and we basically invert both of them. So let's invert the y. How do we do an invert? So simply we multiply that with a float. Oops, not with a vector. We multiply that with a float. Float times float. There you go. -1, right? So if it's negative, it becomes positive. If it's positive, it becomes negative by multiplying it by -1. And let's do the same for the other one. Let's give that a try. Okay, so I could see that for some reason my x-axis is still wrong, right? If I move back, I'm moving forward. If I move forward, move back. If I move left, let's see. That's strange. We're getting the same result as the first time we've tried it, even with an inversion. So let's have a quick look at why that is. So that seems fairly straightforward. And I'm gonna move to the move pawn and see if we're doing it right from here. All right, so that looks correct. Let's go back to the event graph. So just glancing over the questions here. So Tom has a question. There is no way, is there no way to sort blueprints so it look less spaghetti branch? You have to do it manually to kind of make it look nice. So we've been doing a little bit of that here. You kind of just move it around, but not automatically. There is, I heard of a plugin that does that. I don't know if it's been released yet. Let's have a look. UE4 plugin, and then clean up blueprints or sort out blueprints. So there was one, I forgot what the name of that is. Was it Kitatus? No. There was it was announced in one of the streams, and that I thought was really cool. There was someone was making one. We'll look at it. I'll look at it later and then post it onto the comment section if I find it. Just don't want to get derailed trying to look for that plugin. But there is a plugin that plugin or a tool that someone is creating that does the automatic, and it was from the demo video that looked really cool. So it can automatically sort out the blueprints and make it look nice, or make it at least readable. Okay, so back to this one, where we seem to have an issue with arctangent degrees, and somehow. Alright, so at this point we should be doing one change at a time. So I'm gonna put back the y-axis. Try it. Okay, so if I press forward and back, so you could forward, I'm moving left. If I move left, I'm moving right. So it's reversed. We need to do that. We need to reverse this. Which is what I thought I did earlier on. Maybe I made a mistake crossing the lines. Alright, so now we're moving forward and back, left and right. If I move, so the y-axis is the forward, and the left and right is the x-axis. So from here I could see that left, right is correct, the x-axis, right? And the y-axis is reversed. So I'm pressing down, I'm moving forward. If I move forward, I'm moving backwards. So if I press forward, I move backwards. So we need to fix that. Okay. So to do that, we'll do this. And that's on the y-axis. And that's, I think, what got me confused. So the y-axis is the north and south, and east and west, or left and right, is the other one. So basically we're doing, that seems wrong, sorry. Yep, so we're doing x and y instead of y and x. And that has something to do with the way the input is, the input values that we're getting from the motion controller. I could explain the angles that comes out from this, but it's relatively easy as you've a lot easier to kind of do it intuitively because you could see what's happening, and that's really cool with doing development in video games. And in VR, you could immediately see the effects. So if we do that, that should work. That's right. So now, okay, I reversed the wrong thing, obviously. So this is the problem with improvement, so it can get a little bit messy. What I'm missing here is, let's put it up so that I don't get confused. It's not very confusing, because instead of y and x, we're doing x and y, right? So I'm gonna move this along like this. I'm gonna put the y-axis here and the x-axis here. Alright, and in the x-axis, sorry, on the y-axis, we need to be able to convert that to, or invert that number to -1, the negative value, and then the x-axis goes to here. Yep. So basically, we've inverted y and x, so it becomes x and y for our needs, simply because of the way the motion controller is sending out its, or the values that the motion controller is giving out to us. And we also need to do an inversion on the y-axis. Based on, this is all based on what we're seeing from the headset, all right? So forward, back, left, right. So now it's moving in the correct direction that I want. And if I go around clockwise, see, and go around counterclockwise. So now I'm just using all the thumbsticks. So, and we're freely moving the way we want. So that's how to create that movement mechanic. So normally when you're doing this for, I guess, for something else or doing any other type of movement mechanic where there's a little bit of math involved, you start off with the math based on what you've learned from school or what you can find out from research. Like you could also Google, like, I've got X and Y axis. How do I convert that to a degree? So then you would come up with the arctangent to function, and then you'll get that, and then try to use it, and then see how it works from within the environment that you're using. So in our case, VR, and in the way the motion controller, the engine sends out the values for X and Y, we found out that the classic arctangent 2, where we input Y, comma X, does not work. So we need to invert them because they appear inverted. We need to invert them to X and Y instead. And we need to do an additional fix to invert the Y, just simply because when we looked at the headset, it doesn't work. So that's the intuitive approach. What was actually happening there is that for the arctangent 2, obviously this was developed way earlier than VR or any of our the gaming engines. So what it was meant to do is to create an angle from, sorry, just got try to find that picture. Yep, from 180 to -180, and the problem is with this, the angle 0 has to be here on this area, and you go, so these 4 quadrants have different angles from what the arctangent 2 function, trigonometric function, was meant to do. So you basically have to remap it, and remapping it involves a little bit of math or a bit of logic, but as I've mentioned, it's a lot easier. That's what's happening on the background, but it's a lot easier to kind of figure it out from an intuitive approach, which you can do with VR. One of the nice things in VR and game programming in general, I would say. All right, so that's the flight movement. So we've done it on the left and then on the right thumbstick. Sorry, on the left thumbstick. So now we can move it to the right thumbstick. So if you've been following so far, let me just commit this first before I forget. So now we have the free movement, 360 movement, right? Commit that in. All right, so we can move this as a function like before. So if you've been following the live stream, we've done that a couple of times. So we refactored and then converted things to a function whenever we want to reuse it. And since I don't want to copy and paste this code and then just do a left and right input, we want to be able to convert this code into a function, which is relatively easy. But as I mentioned, the part of the stream was to look at Blueprint to UE flavored C++ and to look at a certain type of development workflow. So one such type is if you're working with something that you're not sure of or not very familiar with and you want to have quick results, Blueprint is perfect for doing prototyping, similar to what we've done here. So we've gone through several iterations just to get this algorithm correct. And it's so easy to test and kind of see visually what we're doing and what's happening, right? In C++, some can argue that it is also quite easy, so it depends on your background. But for someone who's familiar with both, it can sometimes be, at least from my point of view and my experience, it's very easy to visually see things or prototype things in Blueprint. And then when we need to make it a bit more professional or performant, then we move it to C++, right? And this is a good candidate for that. And the question is, maybe you would be asking, is why? So everything, especially in VR, a lot of our resources are heavily used. So CPU and GPU. So most of the things that happens are in GPU, in the GPU side. That's where the bulk of the resources go. But if you have, for example, too many draw calls, that also impacts the CPU. If you're going to publish for PlayStation with a more limited CPU, then you'd be more concerned of the CPU. If you're doing a lot of algorithms, it can all pile up. So if you have a lot of things happening on the CPU, so sometimes a lot of it is better moving them into C++ for better performance. And at the moment, all of these are relatively quite basic, but they can be good candidates to be moved to C++ simply because you might want to add more stuff into it, make it more complex in the future during the iteration of your project or during the evolution of your project. And yeah, and they do pile up. So if right now we only have the pawn, right? So if we're interacting with other objects and all of them taking up CPU cycles as well, so the game thread might take longer and all these things. So it's always good to kind of have a step back, prototype, and then see if we can convert to C++. And C++ in Unreal is nothing to be really afraid of, and you can see why in a second. And I hope I do it justice with what I'm about to do. All right, so now I want to, what would be good candidates for converting to C++? Everything that happens per frame, because it happens in VR. So if we're doing it right, if we're doing all of our stuff right, we should be hitting 90 frames per second, right? So there's a lot of things happening in one frame. So, I mean, in 1 second, we're hitting like 90 frames. So this gets run, for example, if we're moving 90 frames per second, and that's something that's better off. Anything that's on the tick would normally be a very good candidate to be moved to C++, so it's closer to the engine code and it should run faster, right? And you could nativize things, but as much good as the Blueprint nativization is, it's not 100% perfect. And obviously the C++ that comes out of it is not readable, so it's not really good maintainable. And as Tom was asking, like, you do get a lot of this once you start getting more complex blueprints out of the way. So far we've done like really basic ones, but moving stuff to the stuff here, right? So we move a lot of stuff in there. Imagine if they're all in here. So they can get look really complex. So a lot of those things we could move out to C++ and have C++ take care of it. All right, so enough preaching. Let's start doing things. So we got the flight movement, right? And I want to be able to move this move pawn, this entire equation here, onto C++. So how do we go about doing that? First thing is, there are several approaches. One is we can create a new pawn from C++ and then create the functions on that pawn, right? Or we could create components similar to my plugin, where you have all of this movement functionality into a component. That's one approach, and then you can reuse that. Another approach, which you'd most likely be using quite often. At the moment, this is very specific to the pawn, but if you have blocks or functions of code that you want to reuse everywhere in your project, you'll be using something called the Blueprint function library. So while technically it's not the best method to use for this, I also want to introduce Blueprint function libraries here, and it's a good segue. If you're just starting out with UE flavored C++, it's a good starting point, in my opinion, to start with something simple such as a Blueprint function library. So what that does is it allows you to create in C++ nodes like this and be able to use those nodes everywhere in your project. So, and that's a power of the Blueprint function library. So I'm gonna be making one from on the C++ side, and we'll be able to use the nodes here inside blueprints. All right, so let's do that approach. So we can do this, add new, and then we add a new C++ class onto our project. And let's click show all classes, and then let's look at Blueprint. So we should be able to get Blueprint function library here. All right, so we've got Blueprint function library, so it's a base class. And well, let's just leave it as my Blueprint function library, or let's just VR. Let's make it a little bit smaller. VRBP function library, okay? And we'll keep that path and create the class. So what will happen now is the code will be added to the project. Your project will be converted to C++. So I should have noted that you would need Visual Studio here, either 2015 or 2017, and then you need to install the C++ modules to be able to move on to the project. So it will convert, now it will convert your project. So you would, from a Blueprint project onto a C++ project. So it has that added, from my point of view, a benefit. So while that's compiling, let's just have a quick look at what we've done so far. All right, so we've created a flight movement mechanic, and we've created a 360-degree free movement mechanic using the thumbstick or gamepad movement. And we've done all that via an incremental approach. And right now, we're looking at possible bottlenecks onto our code and moving that to UE flavored C++. And the approach we're taking at the moment is to create a Blueprint function library for that. So you can do this kind of approach if you want like quick results, which works very well with an agile development methodology, or if you're working with a theme and you're doing agile, it works really well because in blueprints you could basically whip out like really quick code and then have a look if it works, and then convert things that could be possible bottlenecks onto C++. Or if you're more on C++ developer, you could also, of course, do all your all your prototyping from within C++, and then do so most of the hard code algorithm coding you would do in C++, and then do a lot of the logic flow from within blueprints. So that either of these methods work, and what I'm trying to advocate is a balance between blueprints and C++. Not pure blueprints, not also pure C++, but use the benefits of both things or both methods to your advantage. So C++ is quite performant, very close, much closer to the engine, and can sometimes be a lot more readable or easier to produce, especially if you're doing mathematical calculations such as what we're doing now. And Blueprint is a lot easier to visualize and see, and a lot quicker to produce things, but it can be difficult to maintain if you have too much of it. So a lot of logic can be placed, or business logic you can place onto to the Blueprint side, and on the C++ side, a lot of the algorithmic logic you can put in there. So things that would be a bottleneck resource-wise. Okay, so not sure. So Visual Studio doing an installation for me in the worst possible moment. All right, so what Unreal does then is after it's done that compiling and it's done this, it would have converted your stuff to C++, and you would notice this, C++ classes. And that's our VR Blueprint function library there. What I'll do now is, it's good if you have two screens, but for this stream, I have only one. I'm gonna do this. Let's see if I can plug that in, this, so I can see them side by side a little bit. Yep, that should do. So we've got the pawn, and what did we say we want to do? We want to convert the move pawn. All right, so in C++, you get a header file, which is the file in C++ where you kind of specify what the functions would look like, and or parameters as well. But let's start off with functions, and you define what the functions are in the header file, and then on the CPP or the C++ file, you define the implementation, so what actually happens with that function. So it's implied that it's public, but I'm just going to type in public there. And then let's define our function. So since this is a Blueprint function library and the function needs to be available all throughout the project, you'll need the static keyword in there. You don't normally need it for most actors if you're just making an actor or whatnot. But since this is going to be available all throughout the project, you need to make it static. You need to specify the return value, which is void, which is nothing. And we called it move pawn on there, but we can make it a little bit more generic here. So we'll call it move actor, which is the name of the function. And we'll put in some input there, okay? So what are the inputs for move pawn? What did we specify? So with the move pawn function, we've got a movement reference, and we've got the forward rotation. Yep, and obviously, since this is a function library, it doesn't know about the actor that it's on now. So we need to also specify the name of, the actor that's actually going to be moved or going to be affected by this function. So let's start off with that. So it's a actor pointer to the actor that we want. So, and then maybe we'll call it actor to move. And what else do we need? We need the movement reference, which we use this uScene component, I think. Yep, uScene component. And then we call it movement reference, it's fine. What else do we need? And we need the rotation. So we're going to do F rotator. And we call it forward rotation, similar to the C++ side. All right, so we basically defined here the function, what it needs to be. So basically it's kind of like this thing, right? So what are the inputs with an additional input for actor to move? So there is a macro for in Unreal Engine that you need to specify so that it can be seen in Blueprint. So you use the U function macro, all caps, and then type in Blueprint callable, and then you could specify your own category. So here I'm specifying VR as a category, okay? All right, so, and that's how easy it is to kind of define that. So kind of make this part of the Blueprint C++ side, or the C++ side. And then we're gonna implement this on the CPP file. So since we're gonna implement it, I'm just gonna copy that definition in there. And I'm gonna put that in there. All right, so don't need the static in there. And we need to specify the class, which is this, comes up there. And use the unbox operator and remove that semicolon. Maybe I'll make this like this while we're working on it. So Alt, this German keyboard. So yep, and then do some curly braces, and we've got the basic implementation. All right, so that's how you would implement this function. Move that in there. New. All right. So let's have a look. We do a check is valid for the movement reference. Anytime you use something like this and you're going to be using that on the code, like a pointer to an object, you'd always want to check, especially once you've converted things to C++. You'd always want to be able to check if it's a valid thing before you do, or otherwise you'll get crashes. So I'll do an if. I'll start off with that, with actor to move. So I'll do a validity check, which is not something you did here because you don't have to specify it because you're already on the actor. But here we need to. So if actor to move is valid, so we're gonna do something like that. So immediately you could see that there's two options, is valid low level or level fast. And then you could see what the difference is. I like using low level. It's a bit slower, but a lot more thorough. So if actor to move is valid low level, okay, so in blueprints you only have one. Then we do the check, another if. Ooh, why did that come up there? Okay. So if the movement reference, I guess I have to kind of speed up a bit, is valid low level. All right, so if the movement reference is valid low level as well, which is what this is, or you could use low level fast. If it's true, we set a rotation, a local value called rotation here, and that's the one we're going to use. So let's just do that. So we declare a local variable. We call it new rotation, right? And we then set the new rotation to be equal to what? We need to use the movement reference, get the rotation. So get component rotation in C++ instead of get world rotation. And that will be the new rotation if there's a movement reference, right? If it doesn't, then the new rotation would be equal to the forward rotation. So you could see from here, it would be equal to this one. So we've basically done this part. Oops. We've basically done this part here. So we haven't done any of the math work here. Not yet, at least. All right, so we could also move this in here because we'll only ever going to be using that from within here. Right. So I want to kind of do some comments here. Check if we have a movement reference. If so, use it. So use the rotation, the direction. Function. Yep. All right. So then we move the actor to new position or new location. Anyways, so that means we do actor to move. So we're doing this now, do to move, and set. We could do transform as well, but since we're only moving changing the location and rotation, we want to be able to just do this. So this is also one of the nice things in C++. So it's a lot more granular. You have a lot more things. And we do the semicolon. And we'll need to put up the values. And I just kind of wanted to show that. So we could do the new location and a new rotation. We have a vector and an F rotator. So those are the things that we're going to do. And I'm just going to press enter here, more for readability. So set actor location. First is the location. What would be the new location? So that's all this equation that we've got in here. So we've got the new rotation. First we have the get actor location. So we get the actor to move. Do we need get actor location? Yep. And then we do I guess we do a plus, just the same as here, right? And then we need the rotation, which is the new rotation that we've got. Okay. So we got the new rotation, and with the rotation we need to get the forward vector. So since it's not an object or a pointer using dot, I'm gonna do the vector. So if you don't know, just type vector, and then you can see, oh, all right, so rotate and rotate, so that's what we need. So oops. Okay, so we need the vector of that and multiply it with the speed. So obviously we've forgotten the speed here. So we're just gonna have that speed in there. I'm gonna add it. Let me just open this up. So I'm gonna do float speed, all right? And then add this here as well. Float speed. And yep, so let's do that. All right, and then that's what we're plugging in for that one. And that's the F vector. That's the first one. Now we need the rotation, which is basically get actor rotation. So actor to move, get actor rotation. And that's it. So we've basically converted this into C++. Let's see if we've made a mistake, which is not unlikely. Let's do the compilation here so you could see. You can do a compilation there, and then it will be hot reloaded. All right, so C++ compile complete. We go here, and I like keeping the prototype just in case, similar to the way we refactored from blueprint code here onto a function. We're refactoring to a C++ code. So now I should be able to call this function. What did we call it? We called it move actor. So yep, there you go. So that function you could see nicely in there. We created in C++. It's now here. And those are the stuff that we want. And so now we just simply, if I can see it, one sec. Click that. So we do movement reference. Would be here. Gonna move that away in there. And then we're gonna have the speed, which is here. So I still want to be able to set stuff in here, right, in the blueprints, just simply because it's a lot easier and doesn't really affect the performance that much. But all of the hard work of moving the actor is now gonna be happening in the C++ area. So then we need, here we don't have forward rotation, and we just have the movement reference. So, and that's it. So this move pawn is now a function inside blueprint. Inside C++. We can delete. So if we're doing this like in a normal way, you would want to test that really quickly, just to make sure it works, of course. If I play that, let's try it. So I'm still able to move using the motion controllers, but not as I expected it. All right, so there's a problem here because we need to specify the actor to move here. So I need to specify self, which is this actor that we're in now. Just gonna do that. And this part of the code here saved us from having a crash. Okay. I'd like to say it was intentional for demo, but I just forgot. But there you go. So it's always nice to do the test. So now I can fly again using the movement controller here. Yeah, I really like flying. So yep, there you go. And all of that now is happening in the C++ side instead of the blueprint side. So when you get to more complex stuff and then do profiling, so we'll dedicate an episode for performance profiling. You could see that, and you should be able to see some differences, some great differences between blueprint and C++. So, all right, so now we can safely remove this. You can even remove that function, but I'm not going to remove it so you could refer back to it after the stream. All right. So now we've done that. And we said we're going to do this one too, which is slightly a lot more convoluted, but we've been able to make it look at least respectable here. So when we move this to C++, that should make it a lot easier. So we can either do only this part here of the equation, or as well as call this, so that we have only one node. So let's do just a single node approach. Theoretically, because we're doing a function library, we should isolate that into one function. But for the purpose of the stream, so that I could show you it calling a different function, so from within C++, we're going to do it that way, that all of these thing in the blue, flight movement, we're going to convert it immediately to C++. All right, so let's look at the input. So do we need any output? So we don't need any output. We only need input. So we need the X and Y, obviously. We again need the actor to move. We need stuff for the move pawn. So that kind of makes it a little bit easier for us to visualize what we need to do. All right, so we're on the home stretch, folks. We're almost there. Let's finish. So, all right, so we've got, although we've done, of course, the mechanics that we wanted to do. So we're doing the extra mile and doing some performance improvements, removing bottlenecks, and just so that you get a feel of, as well, of the C++ end of things. All right, so I'm just gonna do basically the same thing. So just copy and paste that part of the code. This up. All right, so instead of move actor, I'm gonna call it move actor 360. All right, I would still need the actor to move. I don't need the movement reference because we're not feeding anything to the movement reference. I will still need the speed. And what else do we need? So the rotation is what we need as well. And we need the axis. So float axis X and float axis Y. Yep, and that should be it. And we copy that and put it here so we can implement it. I'm gonna do that so I can see everything. So that and that, in case you're not familiar. Void. And what else do we need? Need the curly braces. Okay. And need the class name, the unboxing symbol, and there you go. You got a basic implementation. It's just nothing. All right, so actor to move. Oh, again, similar. We have this. We're going to be moving it. It's critical to this function, so I do an if. We do. Why don't we just copy this? Oops, sorry. We just copy that. Make it simpler. Not there. Yep. So I have to check if it's valid, and then we can do safely do stuff in here. All right. So let's have a look at the code. All right. So initially we need to check the X and Y values if it's not equal to 0. Right. The axis X and Y. So, and that is a cause of all these things in here. So look at the number of nodes there and a lot of the crisscrossing. And let's see how nice it is in C++. So if basically axis X, axis X is not equal to 0, and or, since I can show you quickly, since if it's true or true, we're not doing true to here, that means an N, like both of them have to be true. So either this is true, not equal to 0, or Y is not equal to 0, so we're using the OR symbol here. If we were doing an AND, like both of them have to be not equal to 0, we'll do this, right? But here it's not. So, and then just simply copy paste that. So Y is not equal to 0. There you go. And that basically does this 4 nodes here in a very elegant, nice to see way. So that's why sometimes it's a lot clearer in C++. All right, so now we want to be able to do this equation here. All right, but we're doing it on the context of this move pawn. So similar to what we've done here, I basically just added it in here. I could have also moved this out and then created a calculation to make it readable, but I kind of like doing it like this, makes it easier and less code. All right, so let's have a look. So we'll need this. Do we do any other checks? No. So then it's simple. So we need to do the movement. What do we need to do? The set. Oh, okay. So the move pawn. So we're gonna call this move actor, the C++ version, of course. And then what do we need? So easily we could see from here, right? Put the semicolon before we forget. All right, so first variable, we need the actor to move, which is basically this. And we're already checking if it's valid, so that's safe to use. What's the next one? Movement reference. So if you remember that if there's no movement reference, it will use a forward rotation, right? So if it's not valid, so we need to put something here that's not valid, and in C++, or at least modern versions of C++, we use null pointer. Points at nothing, pointer that points to a pointer, null pointer, and then we need, sorry, I lost my space there, yep. We need the speed, which is, we're gonna input in there, so we need speed. And that's it, and then we need the rotation. So, and that rotation is the algorithm, or the, not really an algorithm, but the equation that we've come up on here. So we've got, so we make a rotation based on these values, right? So to do that, we do f rotator, and just gonna, oops, gonna move that down. So we have 3 values. So what are those 3 values? I should have shown you. So we're gonna create f rotator. So that's a constructor. It's called constructor, and we're gonna find the one that's correct. So we need the pitch, yaw, and roll. So pitch, yaw, and roll. So in C++ it's pitch, yaw, and roll. In blueprints it's roll, pitch, and yaw. In the viewport it's XYZ, whatever on that thing. So it's one of the annoying parts in Unreal, to be honest. It's these things that are slightly different, especially if you're juggling between artwork, between blueprints and C++, that they're not consistent, possibly due to historical reasons. Yeah, but we just have to live with it for now. And I guess changing it might break other legacy code, so maybe the reason why they haven't tried to fix it. All right, so we've got pitch, yaw, and roll. So fire, a mnemonic device you could use to kind of remember that. So C++ it's fire. So f rotator. So we need the pitch. We're not changing anything on the pitch. We're changing everything on the yaw, if you remember. So on the pitch, we're just gonna get the current pitch. Get actor rotation, right? And is it the actor rotation? Yep, so, oops, sorry. Wrong place. Yep, so it's the actor rotation, so we need the pitch. That. Okay, and then we need the yaw, which is the one that we're calculating, which is this. So let's put this back like this, so we can immediately see between the two. All right, so we need the x and y axis to a function called a tangent 2. So degrees. So a tan 2. There's an a tan 2. Well, that's C++. So in Unreal, let's use Unreal. So fmath. Most likely you'll find things in fmath, which are the engine stuff. And we only have the classic arctangent 2. Right? So we only have this. And then we put axis x and axis y. That means it will come up in radians instead of degrees, like not like this. You can use the Kismet math library. So Kismet is the original, yeah, I guess the legacy name for blueprints. So it was used to be called Kismet, and we could access this node by, if you can't find the it from here, you could use something like this. So sharp include Kismet thing in blueprints, and then so this gives you access to everything that Epic engineers of Epic engine engineers have done. And then you could, it's all, if you have the source code for the engine, it's also a great way to kind of see how they do things. So then I could do Kismet math library. We unbox that class and find, we should be able to find arctangent 2. Yeah, so now you have the degrees arctangent 2. So you could use that instead. We'll do it the classic way. Simply this, just so that it's, because it's not really that complex. All right, so we'll do it the classic way, just pure math, C++ side, a pure engine math. I tend to like to do it that way, a more simpler way, unless there's like really a complex equation in there. So, well, there's not really, I would guess. It will just do the 180 degrees and then divide it by pi, to convert the radians to degrees. So we can do that ourselves. So let's do that. So f math there, and we push the x and y, and on the y, we're multiplying it by -1. So let's do that. Right. And what else do we need? So roll. So pitch, pyre. So pitch, yaw, and roll. So we need the roll here. So you can see with this simple thing, we've basically done all of these things, all of these nodes here. In all of these nodes plus that node as well. So you decide which one's more readable, but all right. So axis x, axis y times -1.f. And you can go overboard with C++. You can also go overboard with the blueprint. So I advocate using both and then just using it when it makes sense for your project. So performance stuff happens in C++, logic stuff that or a lot more visual stuff, a lot better to happen in blueprints, in my opinion. All right, so because all of these things I could have done in C++ as well, but it would take me a lot longer and it'll be a lot more difficult to visualize, obviously. But this is a lot easier for me, my point of view, to do equations like this in C++, and a lot of the logic happens here, a lot of the other basic logic. All right, so actor to move, get actor rotation. So we've got pitch, yaw, and roll. We've got that. Just double checking that I didn't mess up something. So yeah, so now we've got radians. This is radians. We need to convert it to degrees. So it's a relatively simple equation. So radians to degrees. So 180 divided by pi times the radians degree, right? So we could do this. 180.f divided by pi. There's a macro called pi with Unreal, and is it an addition or multiplication? I'd say Yep, so it's radians multiplied by. So there you go. So then that would convert it to a degrees. And that should work. Okay. Or you can even use similar to what I've shown you later. Let's see what the engine actually does. Kismet. So if we use that node, I guess it's a good segue and for me to verify stuff. Kismet math library, right? So we do uKismet math library 8 and 2 degrees, I think. Yep. Okay. So if you want to see how Unreal has done this, so I've noticed that there was an inline code for this. So we could, even without the engine code, we can actually right click on it, peak definition, and see how Unreal does it. So, well, okay, so you see that it does that actually. So it does exactly what we've been doing. So 180 divided by, so that's all it does. And I think that's similar to what we've done, isn't it? Yeah. So there's nothing really special, I would say. So they're doing as well the fmath, not the classic C++. So, and then yeah, so they've come up basically with the same thing. So we don't even need that because it's relatively an easy equation. But if you ever wondered how Unreal does things, or from the blueprint side how they're converted to C++, you could have a look at that code. So I guess I'm just using the parentheses to kind of make sure that the order of operations are correct. All right, so not technically necessary, I don't think, but all right, so pitch, yaw, and roll, and that should be it. Unless I forgot something, which is sometimes likely, most oftentimes likely. So sometimes you have all these asterisks going on, so you can do a save all. I think it's Control-Shift-S, if I remember correctly. Control-Shift-S, yep, and then saves everything. And then, all right, so we're gonna compile. And we should have a new node called MoveActor360, which is the the C++ version of the blueprint project that we just created. And we've got a failure there. Let's have a look at why. Nothing to panic about, I hope. Okay, not sure what it means. Line 44. Term does not evaluate to a function taking 0 argument. What? 0 arguments. Which term? Right. So actor to move, get actor rotation. Be the pitch. Is it not a method? I thought it was a method. Let's see. What's pitch? Oh, pitch is a variable. So it's not a method. So yep. So it's not a getter. So it's just a plain variable. So I'm gonna pitch, yaw, and roll. Sorry. That. Compile it. All right, so, and somewhat safe. Let's see to just test it. I'm having tracking problems with my right hand, obviously. Alright, so, well, we haven't added the code in, so I won't do much. Alright, so we need to, let's do it from the right. So the left does that. So move actor 360, right? That's our that's the node, and then we'll need the event. Motion controller right, thumbstick X. Oops. Sorry. Thumbstick X. Right. And then thumbstick. Thumbstick. Come on. Yeah, there it is. Right. Thumbstick Y. And we simply then need to plug in X and Y, and then the speed, which is here, and the forward rotation. We don't need the forward rotation here, actually, because we're doing that. We're calculating that. So let's just fix that quickly. Otherwise we have an extra thing in there we don't need. Right? Move that from there and remove it from here. Then we compile. Should come up with an error, but we'll fix it. Okay. Oh, yeah. Typo. Sometimes happens. Oh. Changed the wrong one here, so should be this one. Yep. Back here. File. Okay, so let's give this a whirl. Forward, left, right. So the left is working. Your C++ code isn't working. Let's see why. Did I? Yeah. Well, it will help if we actually connect the nodes in, right? The execution pins, right? All right. So let's refresh this because we shouldn't be anything in there. It's a little bit of crisscrossing, but overall hell of a lot better than this. So got that. Here, play. Left hand. Oops, right hand still doesn't work because we haven't set the actor to move. So we do self. Okay, now it's a little bit messier than what I would like. Let's put the speed here, like this. And let's do it like this. I'll double click there and do it here. So this is more just like visual stuff to make it look a lot nicer. Okay, of like straight lines. There. Yep. So it's a bit of crisscrossing. That's an annoying bit there. Maybe kind of like this. Yeah, that should be okay. Alright, so let's try this. Alright, so now I'm doing the thumbstick movement all within the C++ on the right hand, blueprints on the blue hand, on the left hand here. Alright, up to you to see what you like best. And just gonna do some more comments in here, but we're practically gonna wrap this up soon. So I'm gonna copy the comment area. So we have flight movement on the right hand. And we'll call it C++. And here we're gonna just specify blueprint. There you go. So we've got the input flight movement in there, flight movement. This is already C++. Right? And I've retained the, because I'm gonna update the GitHub repository in a while. And so at least you could have both the blueprint version, which is here, and the C++ version, which is this one here. So just gonna keep both for your reference. So let's just be consistent with this here. Here, make it a bit more nice. Okay, that's fine. And let's move this along here. I'm keeping this out of the way because they're quite critical nodes, so you might want to add on to like event begin play and event tick. So it's kind of like easier to spot, right? So there you go. So we've kept that somewhat nice and tight and clean, and yeah. So we've got flight movement, blueprint, and C++. All of the blueprint stuff is still here in case you need it. And yeah, so that's a combination of using blueprint and C++. So if we go back to here, let me just save that. And if I can find source tree, stage all. We committed. And well, that's meeting, so you can grab that on the get on my GitHub account. And let's just go back to this one. So we've basically gone through all of this. So we've gone through a lot longer than I thought. So it's basically like 2 hours. So you can imagine if I chose the teleport, that would have taken us longer. Anyway, so we're looking at locomotion. So we've done the flight movement using blueprints. We've also done the free movement, 360 degrees within one axis using the thumbstick or gamepad. Yep, so that's one, which is somehow quite popular. And VR development workflow, which is what we followed all throughout this. So the approach of creating all of the key things, like the very basic stuff, and then adding complexity on top of each iteration. So we do it in an iteration approach, iterative approach. And then we have a problem pronouncing that. All right, so and then we have blueprint to, and then we took a step back, looked at our code, and saw some potential bottlenecks that we should be able to convert to C++, namely things that happen on the event tick or happens every frame, like this one, since they happen every frame, like the thumbstick, and the event tick happens every frame. we moved all of the core stuff and algorithms and all the calculations onto the C++ end of things. So they run a little bit natively, native C++, and unlike the nativization, it's hopefully a lot easier to read and modify at some point. Okay, so got all of that in there, and they should put some stuff in there, some oxygen type comments, but yeah, so, and that in a nutshell is it, folks, and we've basically gone through it. So Q&A, if there are any questions. All right, you're welcome, Tom. So if you have any questions, just plug them in. Gonna wait for a bit. And on your own challenge, so I'll give you a challenge. So on your own, if you look at this, I'm doing both flight and 360 movement, right? And I'm doing left and right trigger. So try making it a little bit more complex in this. So you could start from this iteration and then create something like, if I press both the left and the right trigger at the same time, I would like to be able to do a calculation on the direction. So where the forward direction is, let's say my left hand is pointing to this direction here. So 45 degrees here, and then 125 degrees for the right. So, and then calculate the midpoint of that and then move forward basically. So you're combining this. So that could be a good challenge. It will allow you to kind of reuse some of the techniques that we've got in here. It sounds somewhat complicated, but I've also shown you a technique on how to do iterations. So start off with something basic like, question is, how do I figure out if the left trigger is already pressed or if the right trigger is already pressed? So that means I need to set up a state or a variable here, right? And then, okay, so how do I calculate this in between? So then you do that, and then you just kind of combine things together and test along the way. All right, so that could be an approach. So that could be a good practice for you guys. So that's on your own challenge. Any questions, posted on the comment section, and I'll try to help along if I find some time during the week. So I'm doing this on Sundays because I have some spare time normally in the mornings right after I get up. So I thought it might be a bit more productive. Yep. So yeah. So it's it sounds a lot complex, Tom. But if you break it down to pieces, like figuring out whether the left and right trigger is pressed, so then you can check if they're both pressed at the same time. So I'll give you a hint: a Boolean field, a new Boolean field, and then the calculation, you should be able to research it. Yep, for the rotations. All right, so, and of course, obviously the stream, although I tried to move on a slower pace, the normal, you might also want to go back to it. So it will be available as well on the YouTube channel, on my YouTube channel. Don't know if maybe I should just show it quickly, but I don't want to kind of make my system slower, but you could look at it from my YouTube channel. Can I show my YouTube channel? Yeah. So you could, yeah, so you could also see it from the YouTube channel or from Twitch. The video should be saved in there as well. And yeah, then you can go back to it and then kind of follow along again. And here you should have in GitHub, did I commit the last one? I think so, yep. In GitHub, you should have all of the source code in there that you can just grab. So you can just grab this here, or if that's too long, just go from here, on Winberg here. My plugin code is there and here. So, and all of that. And also, just a short note, the plugin that I have uses some of this code, but I've taken the approach, obviously, of a movement component that so it's going to be, if you're using my plugin, you just basically have to add a new component called movement component, and then just I have the same things like the flight movement, which is the basic move things, and you also have the 360 as well already done for you. And if you want to see how I've done that, the source code is available here. So you could go plugins and then look at the source, and then you could see in the movement component how I've done the location. It's a little bit more complex than the one we've done, obviously, because it does a lot more than the movement that I've shown you here. It does a bounce to movement, and I tried to make it as flexible as possible. So then you could do nav mesh so that you can only move to set within a nav mesh bounds, like a teleport. So it does that. And yeah, so it does a couple of other things. It does like a speed multiplier to do acceleration. You can do a time dash move, so you can move in a certain direction and then just dash towards it. Yeah, so it does, and then we have something similar, enable 360 movement. So yeah, and you can lock the different pitchio and roll stuff. So you could see how I've done that from my plugin if you want. So it's not a secret. It's there for everyone to learn from and use freely. It's under the MIT license, so feel free to use it on your own projects. And yeah, and for this one of what we've done, if you want to follow along and kind of use it as a reference, you've got it here. So master is episode 2 at the moment, so this recording. Episode 1 is there, and if you click on commits, you should see all of our commits in there. Okay, so and that's it, folks, and thanks for tuning in. And just one last look at the questions if there are any. All right, so thanks to Tom, and there's okay, so all right, and that's it. Thanks, folks, and I hope to see you on the next one. I'm taking suggestions on what you want to see for the next stream. At the moment, I'm thinking of doing the gaze component, where you're gazing at something and then it enables an action. So we can redo that in C. There's also a gaze component in my plugin, but we can redo that from blueprints and then move that to C++ so that you see the process, one way of doing it. So when I did that entirely from the C++ end. But I can show you like prototyping from Blueprint and then to C++, and that's going to be the theme of this live series. So trying to balance both Blueprints and C++. All right, so I won't hold you out for long. Thanks so much for listening, and see you next Sunday. Cheers, bye.